So, welcome to week two. We're going to talk about types of information systems in IT infrastructure. We're going to move from understanding information systems and infrastructure components to evaluating how infrastructure choices support strategy, performance, and managerial decision making. So, this session is organized to move from foundational concept to strategic application. And we'll begin by looking at the different types of information systems and the roles that they play at operational, managerial, and strategic levels of the organization. And from there, we'll shift to the major components of IT infrastructure, including hardware, software, networks, data storage, and we'll examine how those components work together to support modern information systems. And next, we'll consider the key infrastructure choices, including cloud, on-premises, hybrid environments, and we'll look at the trade-offs organizations face in areas such as cost control, flexibility, scalability, and risk. And then finally, we'll connect these ideas into managerial thinking by examining how infrastructure decisions influence organizational performance, strategic alignment, and business value. And then we'll close with a discussion and application so that you can relate these concepts to real-world organizations and real systems. Types of information systems and IT infrastructure. IT infrastructure is the technological foundation that enables organizational information systems to operate, connect, and create value. And we'll begin by looking at the technological foundation behind modern information systems. And when people think about information systems, they often think about the application they can see, such as a student portal or a payroll system or some kind of customer relationship management system or enterprise platform of some kind. But underneath those visible systems is a larger infrastructure that makes everything possible. The IT infrastructure includes the hardware, software, networks, data storage, and supporting services that allow information systems to function. It's the foundation that enables communication, processing, storage, access, and reliability across the organization. And all this matters from a management perspective because infrastructure is not just a technical issue. Infrastructure decisions affect performance, cost, scalability, security, and the organization's ability to support strategy. A strong infrastructure helps systems run effectively and supports organizational goals. A weak infrastructure can limit performance, create risk, and constrain innovation. So as we move through this week, we'll think about infrastructure not as a background technology, but as a strategic foundation for how organizations operate and compete. Information systems depend on multiple components working together. An information system creates value only when technology, data, people, and processes work together as an integrated whole. This slide reinforces that an information system is more than just software. We think of an information system as a visible application on the screen, but in reality, an information system is made of several interdependent components that must work together. Technology is one part of the system, including hardware, software, and networks. Data is another essential part because systems are only useful if they collect, store, and process meaningful information. But information systems also depend on people because users, managers, analysts, and IT professionals all interact with the system in different ways. Finally, process matters because organizations use systems to support workflows, decisions, communication, and daily operations. And the key idea is that these components do not create value independently. A strong software platform without good data, effective users, or clear business processes will still underperform. Likewise, good people and processes can be limited by weak technology. Information systems create value when these elements are aligned and functioning together. The system view is important because it helps us move away from thinking about technology in isolation. Managers need to evaluate, not just judge the tools themselves, but also how those tools connect with organizational work, people, and information. Different information systems support different organizational needs. Organizations use different types of information systems because operational, managerial, and strategic decisions require different kinds of information and support. The image on this slide shows that not all information systems serve the same purpose. Organizations rely on different systems because different levels of the organization have different responsibilities, different time horizon, and different information needs. At the operational level, systems are designed to handle routine day-to-day activities. These systems capture transactions, process orders and record payments, manage inventory, or support scheduling. Their main purpose is efficiency, consistency, and accuracy. At the managerial level, systems help managers monitor performance, review trends, and make decisions. These systems often summarize operational data into reports, dashboards, and analytical tools that help managers understand what is happening and where action may be needed. At the strategic level, executives need broader, higher level information that supports long range planning, competitive analysis, and major organizational decisions. These systems focus less on individual transactions and more on patterns, trends, forecasts, and organizational direction. The important point is that information systems should match the level of decision making that they're intended to support. A system designed for operational efficiency is not the same as a system designed for strategic planning. And understanding that distinction helps managers evaluate whether the organization has the right systems in place for the right purposes. Transaction process systems support daily organizational operations. These systems are essential because they capture and process the routine activities that keep organizations operating efficiently and accurately. The transaction process systems are often called TPS, transaction process systems. These are the systems that support the routine day-to-day operations. They handle high volume, repetitive transactions that occur continuously in business environments. Examples include recording sales at a checkout register, processing payroll, updating inventory after a purchase, scheduling appointments, or tracking shipments. These are not usually the systems executives talk about most often, but they're absolutely critical because they keep core operations moving. The value of transaction processing systems comes from speed, accuracy, consistency, and reliability. They reduce manual effort, standardize routine work, and make sure that the essential business records are updated correctly. When a TPS works well, operations are smoother and the organization can trust that its daily data is current and accurate. This also matters because many other systems depend on transaction data. Management reports, dashboards, forecasting tools, and even strategic planning often begin with data generated by transaction processing systems. So even though TPS operate at the operational level, their impact extends throughout the organization. The key takeaway is that these systems form the operational backbone of the business. If transaction processing systems fail, daily work slows down, errors increase, and decision-making becomes less reliable because the data foundation is weakened. Management and decision support systems turn data into insight. Management information systems and support systems help managers interpret operational data, monitor performance, and make more informed decisions. We move from operational systems to systems that support managers more directly here. Transaction processing systems capture the raw data of daily business activity, but managers need systems that organize, summarize, and analyze that data in ways that support oversight and decision making. That's where management information systems, or MIS, and decision support systems, or DSS, become important. A management information system typically provides routine reports, summaries, dashboards, and performance updates. These systems help managers see what is happening across the organization and identify trends, issues, or areas that need attention. MIS is especially useful for monitoring ongoing performance and supporting structured decisions. A decision support system goes a step further by helping managers analyze alternatives, examine scenarios, and work through less structured problems. These systems might include forecasting models, analytical tools, or interactive data exploration that support judgment and evaluation. This distinction is useful because it shows that not all manager-focused systems do the same thing. MIS supports monitoring and reporting, while DSS supports deeper analysis and decision-making. Both are important because managers need more than raw data. They need information that's organized, meaningful, and actionable. The takeaway here is that managerial systems help transform operational data into insight. They allow managers to move from simply recording activity to understanding performance and making better decisions. IT infrastructure consists of interconnected technology components. Hardware, software, networks, and data storage work together as core infrastructure that supports modern information systems. Here in this slide, we shift from information systems to the underlying infrastructure that supports them. The key idea is that IT infrastructure is not a single thing. It's a set of interconnected technology components that together create the environment in which information systems operate. First, hardware includes the physical devices organizations rely on, such as computers, servers, mobile devices, and other equipment used for input, processing, output, and storage. Second, software includes operating systems, applications, and enterprise platforms that tell the hardware what to do and allow users to perform tasks. Third, networks connect devices, users, and locations so that information can move across the organization and beyond it. Finally, data storage provides the means to save, retrieve, protect, and manage information that the systems depend on. These components are closely related. Hardware without software has limited use. Software without reliable networks may not be accessible when needed. Systems without adequate storage can't not preserve or protect organizational data, and the organization depends on all these systems working together. From a management standpoint, this matters because infrastructure decisions affect performance, reliability, scalability, and cost. Managers need to understand that information systems don't stand alone. They operate within an infrastructure environment that must be designed, maintained, and aligned with organizational needs. The takeaway here is that modern information systems depend on coordinated infrastructure, not just single technology. Computing performance depends on how hardware components work together. The CPU, memory, storage, input, and output devices work together to process data and deliver usable information. Here we look more closely at the hardware side of IT infrastructure by focusing on the major components of a computer system and how they interconnect. The important point is that computing performance is not determined by one part alone. It depends on how several hardware components work together as a system. At the center is the CPU, or central processing unit, which executes instructions and performs calculations. It's often described as the brain of the computer because it manages processing tasks. Working closely with the CPU is memory, especially RAM, which temporarily holds data instructions that are actively being used. RAM allows the system to process information quickly because it provides fast access during current operations. Storage plays a different role. While RAM is temporary, storage devices such as hard drives, solid-state drives, and other storage media retain data for long-term use. This is where files, applications, and system data are saved when they're not actively being processed. Input devices such as keyboards, scanners, or touchscreens allow users or systems to enter data. Output devices such as monitors, printers, or speakers communicate results back to users. These components work together in a continuous flow. Data is entered through input devices, processed by the CPU with support from memory, saved or retrieved from storage, and then delivered through output devices. Managers do not need to become hardware engineers, but they do need to understand that performance, speed, and user experience depend on how effectively these components function together. The key takeaway here is the computer hardware should be understood as an integrated processing system rather than a collection of separate devices. Networks extend the reach and value of information systems. Networks are essential because they connect users, devices, systems, and locations so information can move where and when it's needed. Here we focus on the network component of IT infrastructure. Networks are what allow information systems to function beyond a single device or a single location. They connect computers, servers, mobile devices, cloud services, and other users so that information can be shared, accessed, and communicated across the organization. A network may be local, such as a local area network within one office or campus, or may span much greater distances, such as a wide area network connecting multiple offices, remote workers, or global operations. Organizations may also rely on internet connectivity, wireless access, and secure remote access tools to support communication and system access. From a management perspective, networks matter because they directly influence collaboration, responsiveness, and continuity of operations. Employees need reliable access to systems and information, whether they are in the office, at home, in the field, or working across organizational sites. If connectivity is weak or disrupted, productivity suffers and service delivery may be interrupted. Networks also play a strategic role because they support integration. They make it possible for data to move across departments, campuses, branches, and cloud platforms that connectively support communication, coordination, and organizational agility. The takeaway here is that networks do more than connect machines. They enable information systems to function as shared organizational resources rather than isolated tools. The cloud infrastructure increases flexibility, but it introduces some new trade-offs. Cloud infrastructure expands scalability, access, and deployment speed, but organizations must also manage security, control, and vendor dependence. Here we turn to cloud infrastructure, which has become a major part of modern IT environments. Instead of relying only on hardware and software located on site, organizations can use cloud services to access computing resources, storage, applications, and platforms over the internet. One of the main advantages of cloud infrastructure is flexibility. Organizations can scale resources up or down more easily, support remote access, and reduce the need for large upfront hardware investment, and deploy services more quickly. This is especially valuable in environments where demand changes and work is distributed or speed matters. At the same time, cloud infrastructure introduces important trade-offs. Organizations may have less direct control over the physical environment and may become dependent on external providers for availability, support, and service quality. Security and privacy also remain critical concerns, especially when sensitive data is stored or processed outside the organization's direct control. In addition, integration with existing systems can be complex. From a management perspective, the cloud is not simply a technical upgrade, it's a strategic choice that involves balancing benefits such as agility and scalability against concerns such as risk, governance, compliance, and vendor dependence. The takeaway here is that cloud infrastructure can create important business advantages, but it must be evaluated and managed carefully as part of an organization's overall infrastructure strategy. Infrastructure choices require trade-offs between control, cost, and flexibility. Organizations must evaluate infrastructure alternatives carefully because each option offers different advantages in control, support, and cost and adaptability. We broaden the discussion from cloud infrastructure to infrastructure alternatives more generally. Organizations do not have just one way to build and manage their IT environment. They can choose from different combinations of on-premise infrastructure, cloud services, software as a service, managed hosting, or hybrid arrangements. Each option involves trade-offs. On-premise infrastructure often gives the organization more direct control over systems, data, configuration, and security practices, but also requires greater internal responsibility for maintenance, support, upgrades, and capital investment. Cloud and software as a service options may reduce the burden of managing physical infrastructure and maybe offer greater scalability and faster deployment, but they can also increase dependence on external vendors and reduce direct control over the environment. Hybrid approaches are increasingly common because they give many organizations the ability to balance these considerations. They may keep certain critical systems or sensitive data in-house while using cloud services for other needs. The best choice depends on factors such as organizational strategy, cost structure, staffing, compliance requirements, performance expectations, and risk tolerance. From a management perspective, the important point is that infrastructure decisions should not be made only on the basis of convenience or trend. They should be evaluated in terms of how well they fit the organization's goals, capabilities, and constraints. Its infrastructure alternatives should be assessed as strategic business decisions, not just as technical preferences. Infrastructure decisions shape organizational performance and strategy. IT infrastructure is strategic because it can enable efficiency, agility, security, and growth, or constrain them when the foundation is weak. We bring the discussion back to the managerial and strategic perspective here. Up to this point, we've looked at the types of information systems, infrastructure components, networks, cloud services, and infrastructure alternatives. Now the key question becomes, why do these choices matter so much to the organization? The answer is that infrastructure decisions directly affect organizational performance. Reliable infrastructure supports efficient operations, timely access to information, consistent service delivery, secure data management, and the ability to respond to change. In other words, infrastructure helps determine how well the organizations can execute its strategy. A strong infrastructure can support agility by making it easier to scale systems, connect locations, and support remote work, integrate platforms, and introduce new services. It can also improve the quality and availability of information for decision making. On the other hand, weak or outdated infrastructure can create bottlenecks, reduce reliability, increase security risk, and limit innovation. This is why infrastructure should not be treated purely as a technical background issue. It's part of the organization's strategic capability. These systems an organization can use, the quality of the data it can access, and the speed at which it can adapt are all influenced by infrastructure choices. Infrastructure is strategic because it shapes what the organization is able to do well, how securely it can operate, and how effectively it can compete and grow. Managers must evaluate infrastructure in terms of business value. Effective infrastructure decisions require managers to assess technology not only for technical capability, but also for cost, risk, scalability, and strategic fits. The emphasis here is the managerial responsibility runs through IT infrastructure. It's clearly technical in nature, but infrastructure decisions are not purely technical decisions. They are management decisions because they affect organizational performance, investment priorities, risk exposure, and strategic capability. A manager may not be the person configuring servers, selecting processors, or managing networks, but managers are responsible for evaluating whether the infrastructure supports organizational needs. That means asking broader questions. Does the infrastructure support operations effectively? Can it scale as the organization grows? Is it secure enough for the type of information being managed? Does it align with budget realities and governance requirements? Does it support the organization's strategic goals? This is why infrastructure should be evaluated through multiple lenses. Technical capability matters, but so do business value, long-term sustainability, flexibility, and risk. A solution that is powerful but too costly, too rigid, or too difficult to govern may not be the right fit. Likewise, a lower cost solution may create hidden problems if it cannot scale or protect critical data. The larger lesson is that information systems and infrastructure should always be considered in the context. Managers have to connect technology choices to business outcomes. The takeaway is that successful infrastructure management means making technology decisions that are technically sound, strategically aligned, and organizationally sustainable. Evaluating real organizational reveals how infrastructure supports performance. So this assertion here is that analyzing a familiar organization helps make IT infrastructure visible by connecting systems, components, and business outcomes. So in this slide, we're looking at the concept from a real organizational setting. And so in this case, I think we're talking about a medical situation. And one challenge with infrastructure is that much of it operates in the background, so people may not notice it until something fails. By examining a familiar situation, we can begin to see how information systems and infrastructure actually support daily operations and broader organizational performance. So for this activity, we can think about an organization that we know well, like a university or a healthcare provider or a retailer or logistics company, a bank, or a government office. The goal is to identify one important information system used by that organization and then examine infrastructure that supports it. And so Here we're looking at the electronic health record system in a medical setting. And we need to consider the hardware that's involved, the software platform being used, the networks that connect the users, and the location and the data storage that supports access and continuity. Then we need to connect those infrastructure elements to business outcomes. How does that system support the speed, service, communication, coordination, decision-making, or customer experience? And then we need to talk about risk. What would happen if part of that infrastructure failed, or if it was poorly designed? Doing something like this should help us move from abstract definitions to more practical analysis. And it reinforces that infrastructure is not just in the technical background. It's directly connected to how organizations operate, deliver value, and manage risk. If we look at it from a familiar situation or from the external situation as a more of a business application, the infrastructure becomes easier to understand when we connect it to that real world activity or that real world system. And we can see how the performance outcomes are related to the infrastructure that we're looking at. An IT infrastructure is a strategic foundation for organizational success. Organizations create more value from information systems when the infrastructure is reliable, integrated, scalable, and aligned with business goals. So we want to bring all the major ideas from week 2 together. And so we've looked at different types of information systems and the infrastructure that supports them. And the central message is that infrastructure is not just a technical background issue, it's a strategic foundation for how organizations operate, make decisions, and pursue their goals. We started by recognizing that organizations use different information systems at operational, managerial, and strategic levels. And those systems depend on broader infrastructure made up of hardware, software, networks, and data storage. We also discussed how these infrastructure components work together and how choices involving cloud services, on-premises resources, and hybrid environments involve important trade-offs. What makes all this significant is the connection to the organization's performance. When infrastructure is reliable, well-aligned, and supports efficiency, access, communication, security, scalability, and better decision-making. When infrastructure is weak or poorly aligned, it can create bottlenecks, risk, and limits on growth or innovation. The management lesson is that infrastructure decisions should always be connected to business value. Managers need to think beyond technical features and ask whether the infrastructure supports strategy, governance, performance, and long-term sustainability. Effective information systems management depends on seeing infrastructure as a strategic capability that helps the organizations function, adapt, and compete. Discussing real-world examples helps us connect IT infrastructure concepts to organizational decisions. So this is intended to be a discussion slide to give you an example of how this would work. The goal is to shift from lecture type contact to this. We've examined all these different points. And so we could start looking at applying these ideas through discussion. That's what the discussion prompt is in this session's all about. So we could think about organization we know well. So it could be an employer, or it could be a university, or a retailer, or hardware, or some familiar organization. And then we want to identify one important information system used by that organization to describe it. And that's basically what the discussion assignment's about this week. What hardware supports the system, what platforms are involved, what networks enable access, how is the data secured, protected, and made available, and then look at what benefits that infrastructure provides, what risk or constraints might exist. And it's a valuable exercise because it helps us move beyond definitions and categories and helps us see that infrastructure is something that affects real operations, service quality, communication growth, decision-making. It also encourages us to think about, as managers, how we consider value, alignment, and risk in information systems. So the takeaway from the discussion assignment is that the application, it can help us turn some of these technical concepts into more managerial understanding. So to conclude here, week 2 highlights strategic importance of infrastructure decisions, that managers create stronger information systems when they understand how infrastructure choices affect performance, risk, and strategic alignment. So we spent this time here looking at information systems, infrastructure components, networking, cloud operations, and infrastructure alternatives. Across all these topics, the consistent theme is that infrastructure decisions matter because they shape what an organization can do. Managers don't need to be technical specialists in every area of hardware, software, or networking, but they do need to understand the consequences of infrastructure choices. Those choices affect reliability, security, access, scalability, cost, and the organization's ability to respond to change. In that sense, infrastructure is not just a support function, it's part of the organization's strategic capability. And so this week we should end the week by recognizing that information systems depend on a solid infrastructure foundation and requires effective management connecting technology decisions to business value. Organizations are more successful when their infrastructure is aligned with goals, governance, expectations, and operational needs. And this also prepares us for future topics in the course because later discussions, including data management, cybersecurity, enterprise systems, and digital transformation, all depend on the infrastructure concepts introduced here. The key takeaway for this presentation is that infrastructure decisions are managerial decisions because they influence performance today and strategic possibilities tomorrow. And thank you